Alright guys, we are going to take a look at using the quadratic formula and leaving exact radicals in that quadratic formula. Now what this does is it just really helps us express our answers as exact values, which we know we're focusing on in this course. Okay, so the first thing that we need to check is that our equation is set equal to 0, which this one is, so we're good to go. And then we want to just list what our a, b, and c values are. So here our a value, which is in front of the x squared, is 3. Our b value is negative 10. Make sure you include the negatives and positives. And our c value is 5. Okay, so now I'm just going to enter this into the quadratic formula, which if you forget, this is your quadratic formula. Okay, so we're just going to enter in our variables here. Okay, here we go. I've entered in all of my a, b, and c values, and I'm just going to go and simplify a little bit here. Specifically, these two negatives, those are going to make a positive. And it's kind of nice just to do this step by step, especially if you're not great at putting things in exactly into your calculator. So we're going to get minus 60 over 6, and then we can simplify once more here. Okay, so this is what we have right now. Normally at this point in grade 10 we would have taken this and just evaluated it on our calculator, get the x1 and get the x2. Okay, this time we're going to take a look at our value underneath our radical, underneath our square root, and we're going to see if we can simplify that at all. Okay, so let's just take a look on the next page here. Okay, so our goal here is to take a look at the radical and see if there are any perfect squares inside of 40. Okay, what I mean by inside of 40 is basically, are there any factors that are perfect squares? Okay, so we can try up to half of 40 to see what things go into 40. Okay, so for instance, we have like 20 and 2, neither of those are perfect squares. We have 5 and 8, neither of those are perfect squares, but there is a perfect square inside of 8. We have 4 and 10. Okay, so 40 is 4 times 10. And I know that I've found the biggest perfect square, which is the 4, as long as 10 doesn't have any factors that are perfect squares. And we know that 10 doesn't really, because there's 1 and 10, and 2 and 5, and neither of those are perfect squares. Okay, so I'm going to separate our 40 into 4 times 10. And what we're going to do is basically just square root the actual perfect square part of this. Okay, so I'm going to square root 4 and get 2, and the root 10 is just going to stay where it's at. Okay, we can't square root that any further. Okay, now to get this in fully simplified form, I want to almost think about this as if it were 10 plus, that's not a very good plus, 10 plus 2x. Okay, in order to common factor this, we would take out a 2 from that, and we would have 5 plus x left. Okay, I'm going to do almost the exact same thing with our square root here. I'm going to take out the 2 from this 10 and this 2. And now I'm going to be left with 5 plus or minus the root 10. Okay, in this case the root 10 is kind of like this x here. Okay, and this is still over 6. Now if I can common factor, which in this case we obviously did, now I can cancel these two things out. So I'm left with a 1 and a 3. And now this looks like it's fully simplified. So we have 5 plus or minus root 10 over 3. Okay, so my first root, my x1, is 5 plus root 10 over 3. That's my first x-intercept. My second x-intercept is 5 minus root 10 over 3. And that's it. There's your x-intercepts.